Here we go again. Cumulative distribution function, big F of x. How do you get that function? Well, if you take the graph of the PDF, which is small f of x, I have it drawn there, small f of x versus x. And you find the probability from the starting value of x, generally referred to as negative infinity. In my diagram, I have it as a. You find the probability or the area under the graph from the smallest value of x to a generic x value as shown there. As shown there. From there to there, all the probability in that region. Then that gives you big F of x. So as I've written here, if x is a continuous random variable with PDF small f of x, then by definition, big F of x right there, is equal to the probability that x is less than or equal to x. And how do you find the probability x is less than or equal to x? You integrate from the smallest value of x minus infinity to that generic x. Now remember, x is not a specific value. X is just the variable x. So once you end up with that function for big F of x, you can put different values of x into that, and you will get the probabilities directly. Right? When we plug a value of x into big F of x, this gives us a probability value directly. Okay, how do you use big F of x to find the probability that x lies between two values? Well, as shown in this diagram here, to find the probability that x exists between x1 and x2, that's the probability that x is less than or equal to x2 minus the probability that x is less than or equal to x1. That should make sense. All the probability from a to x2, or from x2 all the way back to a, and subtract the probability from x1 all the way back to a, and that will give you the probability that x is between x1 and x2. This region right there. And because big F of x is defined as the probability that x is less than or equal to x, then the probability that x is less than or equal to x2 is big F of x2, and the probability that x is less than or equal to x1 is big F of x1. So you can use the CDF, the cumulative distribution function, big F of x, to find a slice of probability between two x values. Okay, how do you use big F of x, or the CDF, cumulative distribution function, to find the quartiles? That's pretty straightforward as well. You plug Q1 into the big F function. Big F of Q1 should give me a quarter. Big F of Q2 should give me a half. Big F of Q3 should give me 3/4. In each case, I'll end up with an equation in terms of either Q1, Q2, or Q3, and I solve for it. Remember, before we had to actually do an integral between the lowest value A and Q1, and then put that equal to a quarter. Well, to find the big F function, we had already done the integration. So there was no need to integrate again. You just plug the Q1 value, or the Q1 expression, into that function, equate it to a quarter, and then solve for Q1. In a similar manner, you could do for Q2 and Q3. The big F function simply accumulates the probability up to a certain value of x. So if you think about it, big F of A is the starting value of x right there. Well, at A, you have not accumulated any probability as yet. So by definition, almost, big F of A would be 0, because you haven't accumulated any probability as yet. And big F of B, you are now on this side. Big F of B means you've accumulated all the probability from the starting value of A all the way over to B. That means you've accumulated all of the probability of 1. So big F of B is 1. Percentiles, that should be pretty straightforward to calculate. By the way, the quartiles are also percentiles. Q1 is the 25th percentile. Q2 is the 50th percentile. Q3 is the 75th percentile. In other words, you're accumulating the probability up to the 25% mark, the 50% mark, the 75% mark. Well, it doesn't have to be 25, 50, and 75. If I wanted the 10th percentile, for example, or the 90th percentile, I simply say big F of, let's say, Q, I'm going to use this notation, Q 10%. That must be equal to, well, how much probability have I accumulated by the time I get to 10%? 0.1. And big F of Q 90%, the 90th percentile, that is equal to 0.9. You solve for the 10th percentile and the 90th percentile in that way. Again, that seems pretty straightforward. Finding small f of x from big F of x. Well, if you think about it logically, how did you get big F of x to begin with? You had to integrate small f of x from the lowest value to a specific value of x, which means if I want back small f of x, I clearly would have to differentiate. So as shown here, small f of x is the derivative of big F of x. The derivative of big F of x with respect to x. All right, enough about the theory. Let's jump into problem number 2. I'm going to look specifically at, I have the problem marked off here, exercise 6D, page 340, number 14. I'm going deep into the exercise right away. Here we go. A continuous random variable x has PDF given by f of x, small f of x is equal to kx for x greater than or equal to 0, less than or equal to 8. F of x is equal to 8k for x greater than 8, less than or equal to 9. Excuse me, and 0 otherwise. First part says sketch the graph of f of x. Okay. Well, k is clearly a constant. K is a constant. I think they said that. I just didn't write it in. K is a constant. And clearly, if k is a constant, then kx, that's a straight line starting at the origin. Everybody knows that. So what we're going to do, we're going to simply plug in the two end values of x equals 0 and x equals 8, and draw a straight line between the 2 points. So when x is 0, k times 0 gives me 0, so I'm starting at the origin, there. And when x is 8, kx is equal to k times 8, or 8k. So this y value there, if I go across, that y value there would be 8k. And this is 8. And then between 8 and 9, the expression is, the function is 8k. So that means it stays at that value of 8k. There. So let me draw the graph in a different color. All the others are guidelines, really. Let me erase this and erase that. The graph that I'm about to draw represents the PDF. There and there. Everything in red is the PDF. Everything else is a guideline. There. Okay. And then, of course, the other value there. This PDF stops at x equals 9 right there. Okay, so sketch the PDF. Find the value of k. We have options. Remember I was explaining earlier, you don't have to use an integration to find it. This one I'm going to experiment a little bit. I'm going to use integration. I'm going to use the shape. You can clearly see you have a trapezium there. Or if you don't see a trapezium, you can break it up into one triangle and one rectangle. So we're going to experiment with this one a little bit. I'm actually going to integrate just to show you that integration works as well as observing the shapes, and calculating the areas of those shapes also work. So let's see. Let's start with integration to find the value of k. I'm going to integrate kx, integral of kx between 0 and 8, because I have to have my dx there, plus integral between 8 and 9 of 8k dx. That must be equal to 1. Let's tidy this up. This is kx squared upon 2, evaluated between 0 and 8, plus 8kx, evaluated between 8 and 9, is equal to 1. Let me plug in my limits. Upper limit, 64. 8 is 64.2 is 32. 32k. Lower limit would give me 0 there. Plus, plug in 9. 8k times 9, 8 9 72k, minus 8 8 64k. And that must be equal to 1. So how many k's we looking at there? 72k plus 32k minus 64k. That's 40k. 40k is equal to 1. K is equal to 1 upon 40. If you convert that to a decimal, I don't know, what's that as a decimal? I don't know my decimals too. 0.025. So K is 1 over 40 or 0.025. Okay. Let me show you your other options. If you had recognized that shape as a trapezium, you could have found the area of a trapezium as half the sum of the parallel sides times the distance between the parallel sides. The area under that curve is half. The sum of the parallel sides are the bottom, which goes from 0 to 9, which is 9. The top, that red portion that's horizontal, which goes from 8 to 9, that's 1, times the distance between those two parallel sides, and that distance is 8k. That's the vertical distance in this case, times 8k. And that area must be equal to 1 because I found an expression for the total area under the graph. Okay, let's see what this works out to be. 9 and 1, 10. A half of 10 is 5. 5 is 40k. 40k is equal to 1. K is equal to 1 over 40. That's not too bad to just recognize it as a trapezium and find the area. Like I said before, if you didn't recognize a trapezium, then you should certainly recognize a triangle plus a rectangle. Let's see. For the triangle, the area would be half base by height. Half, the base is 8, and the height is 8k. There. And for the rectangle, the base is between 8 and 9, which is 1, times the height, which is 8k. And that must be equal to 1. 64, half of 64 is 32. 32k plus 8k is equal to 1. 40k equal 1. K is equal to 1 upon 40 again. So we are spoiled for choice, spoiled for riches. We have a bunch of different ways in which we can approach the same problem. Just give me 1 minute. Okay, I'm back. So, several ways in which you can find the value of k. Sketch, find the value of k. Determine for all values of x, the distribution big F of x. Now, I'm going to slow down here a little bit because a small part of this is a little technical, and most of it is not that technical. So, how do we start accumulating this probability? So here's what we're going to do. We're going to find some generic point here. We're going to call that x. And then for the first part of the function, notice that that region there is within the first part of the function between 0 and 8. So whatever I do with that first portion has to be only for x between 0 and 8. So for x between 0 and 8, big F of x, remember, it's the probability that x is less than or equal to x which is equal to the integral between minus infinity and x of small f of x dx. Okay, let's interpret that. Big F of x is equal to the integral. Negative infinity simply means what is the starting value for your x, for your range of values of x. And clearly the starting value there is 0. So from 0 to x, some generic x, again, x doesn't have a value at this point. X is just the variable x. So between the starting value and x of f of x, and what's the f of x function in between 0 and 8? It's 8, it's kx. So it's equal to kx dx. But remember, we found the value for k, right? So we can plug it in right now. 1/40th integral, I pull the constant out, integral of x dx between 0 and x. Big F of x is equal to 1/40 times x squared upon 2, evaluated between 0 and x, which gives me 1/80 into, if I plug in my upper limit, plugging in x for x, I get back the x squared, and plugging in 0 for x, I get 0, I'll get 0. So x squared minus 0. So for that first part is 1/80x. Just give me a second here. (0.0125). Yes, 1/80 is 0.0125. I'm going to leave it as diffraction. So if I were to summarize what I just did there, for x between 0 and 8, big F of x is equal to 1/80 x squared. Now, what I have to do, pay careful attention, this is where it gets a little technical. I have to find x between 0 and 8. I have to find how much probability I have accumulated at the end of this range. And at the end of this range, x is 8. So when I find big F of 8, let me put it in the next line. When I find big F of 8, that will be 1/80th into 8 squared, which is 64/80, which is 16/5 is 80. That's 4/5. I've accumulated a total probability of 4/5. And I get that by just plugging in the last value of x for that first portion into the big F of x function. You can see it makes sense, because if you were to actually go back to the diagram and look at that, just a triangular piece, that area is half the base times the height. Half of 8, which is 4, times the height, which is 8k. K was 1/40, 8k would be 8 1s 8 5 1/5. So it'll be 4 times 1/5 or 4/5. So I would have accumulated a total probability of 4/5 at the end of that triangular portion. All right. And I can get that directly from the big F of x function. The next thing I want to do is check what's happening between 8 and 9. For x between 8 and 9, remember I have another part of this function that exists between 8 and 9. It's 8k. Small f of x is equal to 8k, and k is 1/40, so that's 8 times 1/40th. So the value of f of x is 1/5. Now I need to find big F of x. Okay, look at the magic. Big F of, for x between 8 and 9, big F of x is equal to 4/5. That 4/5 there, which is all the probability I accumulated at the end of the first portion, plus the integral between minus infinity and x for f of x dx. So let's see how that shapes out. Big F of x is equal to 4/5 plus negative infinity for that second portion that exists between 8 and 9. Negative infinity simply means the starting value, and the starting value is 8. So I'm integrating between 8 and some x value. The f of x function, and I just found the f of x function for that portion to be 1/5. So 1/5 dx. You have to add all the probability that you accumulated in the stage before to what you're going to accumulate in the next section. So let's see how this shapes out. Big f of x is equal to 4/5 plus, when I integrate 1/5, I get 1/5 x. And I'm evaluating that between 8 and x. Big F of x is equal to 4/5 plus 1/5 into x minus 8. Tidy that up a bit. That's 4/5 plus 1/5 x minus 8/5. 4/5 minus 8/5, I think that's minus 4/5. So therefore, this is equal to 1/5 x minus 4/5. Okay, so here are all the important parts. For x between 0 and 8, the function is this guy. Then I added up, found all the probability at up to and including the end of that range, or end of that domain. Found that to be 4/5. And then for x between 8 and 9, big F of x is 1/5 x minus 4/5. So I have to summarize all of that now into one function. Let's see how I do that. Before I summarize it, I want to add up and accumulate all the probability up to the end of the second domain. So let's see. I have big F of x is equal to 1/5 x minus 4/5. This is for x between 8 and 9. And then I'm going to plug in the upper limit there. Big F, you can kind of figure out what value you're going to get. When I plug in 9 into big F of x, I'm saying I'm accumulating all the probability up to and including x equal 9. And because x equal 9 is the last value in that domain, then I clearly would be accumulating a total probability of 1. Let's see if it makes sense. Big F of 9 is equal to 1/5 times 9 minus 4/5, which is 9/5 minus 4/5, which is 5/5, or 1. Makes perfect sense. So here's the way I'm going to write the big F of x function. Big F of x is equal to, I'm going to say it's 0 for x less than 0. I'm going to say it's 1/8 squared for x greater than or equal to 0, less than or equal to 8. I'm going to say it's 1/5 x minus 4/5 for x greater than or equal to 8, but less than or equal to 9. And then it's 1 for x greater than or equal to 9. That should make sense. The f of x will stay at 1 because by the time you get to x equal 9, you're not accumulating any more probability. So even if you go to x equal 10, you still have a total probability of 1. You go to x equal 12, you still have a total probability of 1, and so on and so on. There's big F of x. Fully formed. Okay, what else was the problem asking for? Calculate the probability that an observation of x exceeds 6. That means you're looking for the probability that x is greater than or equal to 6, or greater than 6. For a continuous random variable, there's very little distinction between the greater than and the greater than or equal to. How do you find that probability? Well, before, you could have used the PDF to do it. Simply find all the area under the graph between 6 all the way up to 9. You could do that, but now we got the big f of x function to help us. Let's see if we can use it. I'll probably go back and do it that way as well. They're asking for the probability that x exceeds 6. Well, big F of x doesn't give you the probability that x is greater than any value. It always gives you the probability that x is less than or equal to a certain value. So the probability that x is greater than 6 is equivalent to 1 minus the probability that x is less than or equal to 6. Guess what this guy is? This is big F of 6. So this becomes 1 minus big F of 6. And to find big F of 6, you just go into the big F function right there. Which portion exists when x is equal to 6? This first portion right here. Don't try any other part. This other part exists between 8 and 9. This first part exists between 0 and 8. So clearly x equals 6 is in that portion. So therefore, this becomes 1 minus, and then you plug x equals 6 into the big F function. 1 minus 1 over 80 times x squared. Oops. I always do that. Times x squared, which is 1 minus 1 upon 80 times 6 squared. 6 squared. But you know the difference between square and cube? So let me see. What do I have here? 36 over 80. And then 1 minus that. 0.55. Probability yes. The probability that x is greater than 6 is equal to 0.55. Not too bad. Could we have gotten the same thing if we had used the PDF itself to do it? Yeah, we would have gotten the same thing, I'm pretty sure. Let's see, x equals 6 is somewhere back here. So we'll be finding the area from 6 to 8, and then the area from 8 to 9. Again, one portion is a trapezium. Between 6 and 8, that is a trapezium. And between 8 and 9, that's a rectangle. If I plug in 6, let's see. I'll do the calculation right here instead of scrolling up and down. Do the calculation right there. Now, the function itself is kx. Remember, k was 1 over 40. So when x is between 0 and 8, f of x is kx, or 1 upon 40 times x. And I'm going to plug the value of x into that. X equals 6. So when x is equal to 6, small f of 6 is equal to 1 upon 40 times 6, which is 3/20. 2 3s 220. 3 over 20. Good. So for the trapezium part, that area is equal to half the sum of the parallel sides. That's the 3/20. The other side is 8k, which is 8 times 1 over 40. or 4 over 8, 8 over 40, or 4 over 20. And leave it in terms of 20ths. Times the distance between those two parallel sides. The distance between 6 and 8, that's 2. Plus the area of the rectangular part, which is the area between the width is between 8 and 9, that's 1, times the height, which is 8k. 8 times 1 over 40, or 8 over 40, or 4 over 20. Let's see how this works out. This is 3 and 4, 7. The half and the 2 disappear. So that's 7 20ths plus 4 20ths. 7 and 4 is 11 over 20. Better be 0.55. All right, going home. 11 divided by 20. Voila. That area is 0.55. So we got skills. We got all kinds of ways we can find it. But my suggestion is, if you have the big F of x function, use it to your advantage instead of going back and recalculating areas or doing any, especially if it's a curve where you would have to actually integrate. In this case, we were a little lucky. Use the big F of x function to your advantage, because remember, to get that big F of x function, you had to do the integration to begin with. So you have already done the integration. Use it to your advantage. All right. That's it for this problem, and I'm going to call it George for this worksheet as well, for this tutorial as well. You got a nice worksheet here. So good luck with that. Yep, there it is. You got two exercises, 6D and 6E. You got a bunch of problems. Yeah, that should keep you busy and out of trouble. And without further ado, I think I'll call it quits for this video. 6D number 14. I don't think I signed that here, did I? 6D, no I didn't. All right, that's it for this video. Peace.